So what happens in that account is that there is an IAM role that is present. And in this case, it's called autoscaling.amazonaws.com. This IAM role is known as the service principal. There's quite a number of service principals, and all these service principals are, or rather, each service has its own service principal. Right. Now, the service principal is going to use the same assume role method that you would typically use on a regular basis. So this assume role method is a API that comes from STS. Now, STS is a service that allows you to assume a role, and when you assume a role, temporary credentials or short-term credentials are created by STS. Right. So the auto-scaling service then makes use of these temporary credentials that were created to call the EC2 public endpoint. When this EC2 public endpoint is called, it also makes use of signature v4 protocol or the SIG v4 signing process. So when EC2 then receives this request, it then uses IAM to authorize the request, right? Then only after all of this has happened, the EC2 instances would then now appear in your account to ensure that there's enough resources to remediate that alarm that went off. So the key takeaway I want you to take from this example is that even though AWS auto-scaling as well as EC2 are from us services, our AWS services, there is no inherent trust or network relationship that's set up, and they also rely on the same network as well as identity-centric methods to communicate with each other on your behalf. Okay. So now I'm gonna get into how you can then achieve zero trust on AWS. And here I'm going to be referring to those two use cases I mentioned earlier, which is machine to machine as well as human to application. Okay, so let's have a first look at machine to machine. With machine to machine, the goal here is to eliminate unnecessary network paths. And we do this by reducing the surface area of the systems. So for people in security, you might have heard this as the East-West security practice or security model. Now, again here, the main goal is that we really want to eliminate those unnecessary pathways of data. So there is something to consider here, and what we need to consider are the patterns follow architectures. So what do I mean by that? I mean basically that the way in which you would solve for a traditional virtual machine is very much different for how you would if you were making use of containers or if you were making use of APIs. Okay, so here's an example, right? This example is a machine-to-machine example where we have a typical three-tiered web application. And this is an employee directory app that allows you to find employees within your organization. Sorry. So this application consists of a load balancer, a couple of EC2 instances, as well as a relational database that runs in the back end. Okay. Now, the first thing that we want to do is to eliminate any unnecessary paths. And we do this by applying security groups, right? So security groups are really amazing because they allow you to control how the different elements of this application are accessed. So that means that the web tier is only accessible from the load balancer, and the relational database is only accessible from the web tier. Now, as your infrastructure grows, you still have the same pattern that applies. And we can also do this for other applications as well. So here we have an IT help desk application that is used as a help desk for your organization. This further, okay, so we get to choose how we get to choose explicitly what is defined and what is not, right? So that means that we are eliminating stuff that is not needed, and everything else is going to be denied apart from what we defined. Okay, so let's start modernizing our application, right? When we modernize our application, we decide to develop some microservices. Maybe these microservices are going to be backed by containers. Now, these microservices in this situation are in different, this could be a different, you could take this as a different AWS account, or you can also take this as different VPCs. But the main aim is to show you that there is no connection between the applications that we already have and these microservices that we would like to interact with. So then how do we enable the communication? Okay. So we could make use of AWS Private Link, which will create an ENI in your VPC. And then it also creates a one-way gateway that allows you then to communicate with the microservice in the other accounts or / other VPCs. Now, on top of that, there's also, you can configure some identity techniques such as mutual TLS or OAuth 2, or maybe even a combination of the two. It's not necessarily one option. So what's really nice is that there is no path, right, to what has not been defined. So right now we only have a path to what we allowed. And remember, everything else is denied by default. And you can also make use of this to interact with other applications that might be available on the AWS Marketplace. So these are all other third-party applications that you might want to communicate with for your application. So what's amazing here is that when things don't need to talk to each other, because we did not define the path, then there is no path at all. Okay. Now let's take another example, right? And let's say we've modernized our employee directory application quite a bit. So we decided to trade in our relational database for DynamoDB. And we've also decided to make use of IAM roles underneath our compute. So this IAM role is then going to automatically deliver and then rotate the credentials that gives these EC2 instances identities. And now we can also make use of SIG-v4, signature v4, that I've been speaking about earlier on to connect to DynamoDB by also calling the public endpoint, right? But also, wouldn't it be great if we use the same AWS authentication and authorization for your own services as well? So these are the services that we spoke about earlier. Okay. So say we have a fleet of services. This time around, your services are backed up by an API gateway. And we're also going to use the same private link mechanism that we used earlier on. So here it's just a VPC API gateway endpoint. Okay, so we can additionally also attach some policies to the VPC endpoints as well. And we can also even attach some policies to the APIs. So when we attach these policies to the APIs, we are actually allowing in terms of what access is allowed and what access is not. If you're familiar with Amazon API Gateway, you will know that access is controlled by making use of a resource-based policy. So in the resource-based policy, then you get to define whether you're going to allow requests from another VPC or not. And there's also other configurations that you can make use on the resource-based policy. Okay. So because we were again making use of the private link technology or the private link mechanism, we also now have a one-way gateway that is being set up, right? And then we have SIG-v4 here that you're making use to authenticate each and every request that is being made to the API on your behalf. And again, we're faced with that situation where there is no path to secure because we didn't define, there is no other path to secure because we didn't define other things that we wanted. So we're basically working with what we defined. Okay. So let's now then come into considering some human to application. So an example, the use case of human to application, right? And the goal with human to application is to really improve the workforce mobility as well as the user experience. So what we want to do here is to make internal applications available from anywhere. And we also want to maintain the security or even sometimes improve the security posture of the applications. Now, this is where you also apply that guiding principle that this is not a one-size-fits-all scenario because you may be working with various technologies or various different applications. So let's take a bit, or rather a moment, to speak about how access is allowed or ways in which users are able to access applications that are sitting behind AWS services. So when you are in an on-prem situation, you typically would have either direct connect configured or AWS site-to-site VPN, and the users that are on-prem would then be able to connect to the AWS cloud via these two methods. However, for your remote users, this is where then you can make use of AWS Client VPN. Okay. But customers really wanted something that offers better solutions and more granular authentication for their applications. And to achieve that, you can place a load balancer in a public subnet, and then you can also shield the application by making use of AWS Shield and AWS WAF. So customers also then opt out to integrate an application load balancer with the corporate identity provider. That ensures that we have some adaptive authentication. And what it does is that it's also going to check the security posture. So what happens is that users are also able to get a SaaS-like experience with managed protection services from AWS, and only authenticated users are able to reach this application. So no other person is going to be allowed access to this. Okay. So the two scenarios I mentioned earlier work. They work for some customers, and many customers are really comfortable with them. But how can we make this better, right? So this is where we're looking at something that's known as Zero Trust Network Access, or ZTNA. This is a solution that augments or rather replaces VPN technology, allowing zero trust aligned controls for accessing applications. So it uses certain signals to allow you then to authorize each and every request. Okay. So while we're talking about a VPN-less secure access, this is where I'm going to introduce AWS Verified Access. So AWS Verified Access is something that was released last year during reInvent. It's quite new still. You should have access to it in your console. I was playing around with it a couple of days ago. But ideally, it allows you to set up applications, or rather to set up connections to your applications, and allows users to connect to your application from anywhere without making use of any VPN or some agents, right? And this simplifies that application onboarding process and access management. So imagine you have a internal application that you need to always access from where you work. And imagine being able to connect to this without having to connect to the VPN. This is literally what that means. So it evaluates each and every request based on the user's identity, and it also checks the device's security posture in real time. What's nice is that you can also get detailed access logging for each and every user request for the application. Okay, so if you then take that application that we had, and now we implement verified access to this. So we decided to then place everything inside a subnet, right? When you place everything inside a subnet, we then place a verified access instance in front of the application. So AWS verified access instance will then get the security posture from the user's browser using a verified access extension in the browser. In this way, we are also able to integrate corporate device management, and we also have a corporate identity provider, which provides us with authentication. And we define certain policies in terms of who can access this application based on AWS verified access. So this really allows you to authenticate and authorize every request that goes into your application. And each and every request will be logged, and you can use this information later for troubleshooting. So that concludes my presentation for the day. But I would really advise you to go and play around with AWS verified access. It's actually really cool. So what happens is that before you make use of it, you need to provide a trusted provider. So you can make use of IAM Identity Center or OpenIDC. Those are the two trusted providers. Then after creating your identity provider or trust provider, you would then create a instance. So this is a verified access instance. Let me actually quickly jump into the console and show you, but I'm not going to be creating the items. I'll just show you I just want to show you the steps really in terms of how you go about using this. In the meantime, you can go ahead and let me know if you have any questions. Actually, it said he cannot see the slides. It seems like there were a number of you who were not able to see my slides. Maybe I could send these slides afterwards. Collins, is it okay if I send them to you and then you can share them with the rest of the group? I don't know if that's possible.
Sure, that's okay. Thank you. That would be great.
Okay, I'll share the slides afterwards. So I'm just going to quickly switch over my screen share. Okay. So you should be seeing the AWS console right now. Now in the console, if you head over to the VPC console, verified access is going to be all the way down here. So how it works step by step is that you're going to have to create a trust provider. Now this trust provider will either or have something. So it's either going to make use of identity provider or it's going to make use of OpenID Connect. For Identity Center, if you already have it enabled, then you can just provide a few of the stuff there. And then for OpenID Connect, you just need to provide a number of the information that you'd have from your trust provider, right? So you'd go ahead and create that. And then after creating it, you'd have it in the console, right? So then the next step after that is to create a verified access instance, sorry. And then to create this, you need to attach that trust provider that was already there. Okay, so once this instance has been created, you can then go ahead and create a group. So basically what a group is a collection of access endpoints. And you can define how you want policies to work hand in hand here. So this is where you'd be defining that policy that you want. You can have multiple endpoints associated with a group. So let me show you this. Policy. So in the policy, this is where you're permitting the principal, the action, as well as the resource. So I'm permitting this. So this is the trust ID for my identity provider. And then I'm also permitting all the users that are available there with the email address amazon.com. So what happened is that I have, I set up I am Identity Center to have a group, and then in that group I have a user, which is myself, and then I specified my email address, right? So after you're done with the group, now you go ahead and you create your endpoint. As you can see, I don't have any endpoints. So I'd specify that group that I had here. And this is where you provide an application domain. So this is where you're going to be sort of like attaching your domain to the endpoint. And then you would also provide the domain certificate ARN. And there's a couple of also attachment types. So there's a VPC, you would associate the endpoint with a security group. Then you provide the endpoint with the prefix, and then you would choose whether you want a load balancer or network interface type endpoint. And you can also ideally optionally set the policy. Now, when all of this is created and you have all the 4 elements, right, over here, you would then, because there's going to be like an ID, an endpoint ID that gets created from AWS verified access endpoint. That endpoint ID is like a long endpoint that you can now go to Route 53 and create a record, something that's easily identifiable, that then will be accessible for your users. So those are just the basic steps. Please go play around with it. Let us know if you have any feedback. Okay. So I'm gonna pause for any questions. And then I'm gonna go back to the survey. Is there a couple of questions?
Hi, Kumaso.
Yeah.
I just want to comment out on a few things that I've learned from this session.
Yeah.
And also to apologize for the bad language that we had earlier on. I think it's safe to say that one of the things that I've learned from this session is not to trust anyone to be who you think they are. I think we got a more practical approach when we had someone join this session. Probably next time we would start off by some sort of verification when sending out invites or when accepting invites for the session. Then coming to your presentation, I did find it helpful in terms of getting to understand the visibility that comes off from Zero Trust. as it provides us with the visibility to track on the users' activities that go on within our compute environment, be it outside the cloud environment, as well as the devices or users that are connecting outside our perimeter. That's all I can say for now. Probably if anyone else can comment out on that or share their insights.
Just something. The person who came, it's okay. You managed to remove them, so it's fine. We moved past that. I'm okay with that. Is there anyone else that maybe wants to add something?
There's a question in the chat.
Oh, sorry, I didn't see that. Can you provide some examples of how God duty, cloud trail, the AWS Life, etc. contributes to the overall posture and the so in terms of I'll get some examples for you. I'm actually not quite sure how we would apply these, but I'll get some examples for you, Hilda, and reach out. I think I can get you via LinkedIn. Can you please send me a LinkedIn link?
Okay,
so
that's fine. In the chat. I had another question. I'll put it in the chat.
Okay, so for some basic services from the top of my head would be number one being AWS verified access, right? You can make use of that. And then there's also something new that is AWS verified permission. So what this does is it gives you attribute-based permissions and role-based permissions for your applications. So I'll also send you the link for that. Okay. Yeah, those are at a high level the services that are based on zero trust that I am aware of from an AWS perspective. But again, also remember I mentioned that we also have Amazon VPC endpoints, and Amazon VPC endpoints also makes use of zero trust. Thank you, Hilda. Okay, let me just connect with you on LinkedIn. If everyone could, with the minutes that we have left, if you could please complete the survey. I sent the link, and you should also be able to see it on the slides. To those that don't have access to the slides, I'll send the slides later on. So if you could please do that. And just also a final call out. If you are looking for any resources, please go here. We do have an AWS summit that's coming up in Johannesburg on the 27th of no, not the 27th, the 26th of September. So if any of you are available in Joburg at that time, it's going to be at the Joburg Convention Center. Please pull through, come have a chat with us, and join the talks that will be happening. So it's going to be one big event for everyone. It's a free event. You're more than welcome to come. Would really like to have you all there. And Ashley, I owe you something. Ashley, can you please also send me your Slack? Is Ashley still here? Okay. Yes, Ashley, please send me your, not Slack, your LinkedIn profile. I'll be at the event. I need to, I'll definitely organize that for you. Okay, let me send y'all the link. Okay, please do register. So here is the link. I can't paste. Oh, since I got completing. Sorry, here's the actual link. Ashley, will you please send me your LinkedIn so that we can reach out and then meet up at the summit so that I can give you your swag?
So I guess that's it from us and our guest speaker, Komoto. I would like to thank you all for joining, and I hope you managed to grasp of some of the insights from Komoto. Thank you.
Thank you very much for having me. I hope we could have another session and maybe next time I'll speak about machine learning.
Sure. That would be great. That would be great. That would be great.
Okay. So I'll
keep.
mm-hmm.
You can go on. You can go.
Now I was saying maybe you can reach out on, because I have your email, right? But I don't have your
Yes.
LinkedIn. So if you could send me your LinkedIn and then you can tell me when you would like the presentation for your people next time. So I'm free whenever you're available.
Sure. Thank you. That would be great. I'll definitely keep in touch with you.
Okay.
On LinkedIn.
Sure.
Sure.
Thank you very much.
Thank you, guys.
Thank you.
You.